Vectors Part 2a, Addition, Subtraction, and Gradient of Vectors. In this part of the chapter, we're going to learn the triangle law of addition. For example, I stay in Ang Mo Kio, point A, and I would like to travel to Changi Airport, okay, to send a friend off. But then my MRT station broke down, or whichever, so I cannot get from A to C directly. So I had to take a transit and take a bus to Bedok and then transit over to the Changi Airport. So now in this case, if I want to travel from A to C, I actually travel starting from A. I travel to B first. So I'm traveling A to B. And then from B, the interchange, I travel now to point C, to Changi. So now I'm continuing from B to the next point, C. As a result, I have traveled from A all the way to C. I started at A and I ended at C. So this will be the vector AC. Now take note, the interchange station over here, B and B, must be the same. So, and not only that, the arrows here does not flow in a circle. Yes, this arrow here is supposed to be the starting point to the ending point. So there is one of the direction that is going against the other two direction. Now this is the triangle law of addition. Now we're going to learn how to do the drawing of the vectors. Now given the two vectors A and B, now A is the vector 2, 3, and B is the vector 3, -1. How do I do a vector addition, A to B? Given for example, let me take this picture. A, here is my starting point. I'm traveling 2 units and 3 units up to the interchange over here. At the interchange, I take a bus B. Bus B here, vector B says is 3 units to the right and 1 unit down. So I end up at here. So I have A and vector B. I started and I ended here. So now I'm going to draw my vector. The vector addition will be from S to E, the starting point to the ending point. And this will be vector A plus B with roller skates. Notice again, the arrow of the direction does not flow. There's one vector that is contradicting the other two arrows. So that is vector addition. Similarly, using the same triangle law of addition, I can do a vector addition for B plus A. If I were to have a B plus A, I'll start off with my vector for B. So this is my starting point. B says 3, -1, and I go to the interchange. Now at the interchange, I take the bus A 2, 3 to end up at this station. So this is where I end. So to join up the vectors, I will join from the starting point to the ending point, and this will be vector B plus A with roller skates. Now how do we do a vector subtraction? Before we do a vector subtraction, B is 3 to -1. What will minus B be? Negative B will be -3, +1. That means I'm going in the opposite direction. Now given the following vectors, let's say how do I find A plus B through the drawing? So I'm going to use vector A. This is my starting point. A is 2, 3. I end up here at the interchange. Now I'm going to take a bus B, but instead of going in the direction B, I'm going in the opposite direction now. That means I'll move negative 3 units, and then I move 1 units up to end here. So this will be vector negative b. Now I started here and I end at this portion. My final vector will be s to e, the vector addition. This will be vector a minus b. So hence, you notice the arrow does not flow. These two arrows flow in the same direction, but this arrow over here is in the contradicting direction. So this is vector subtraction. Let's get ready to do some drawings. Now, next part, we're going to do a vector subtraction for b minus a. So how do I do b minus a? Now, in this case, I'm going to look at the vector a. A is given to be 2, 3. So if I'm going to do a subtraction a, negative a, it'll be minus 2, minus 3. So if I were to do a b minus a, I'll start with my vector b first. So starting point of b is down here, and b will reach this interchange. Now I'm going to do a negative 2 and negative 3 units to reach the vector a. So this is going to be negative a. So as a result, I started here and I ended here. So this will be vector b minus a. Observe that b minus a and a minus b are different. They will result in a different direction. This vector here is going downwards, whilst a minus b just now was going upwards. So they are negative vectors of each other. In the next part, let's do some drawings. Before we do the drawings, it will be helpful for us to identify all the different vectors in its column vector form. So what are all these vectors in column vector form? I will have a to be 3, 2. B will be negative 3, negative 1. Oh, sorry. B is 3, negative 1. And C to be negative 2, negative 4. Vector C. Vector D will be negative 2, 0. And we'll use them to find out the other vectors during the drawing. How do we do vector drawings for this following? Vector A plus B. Now let's start off with vector A. Vector A will be, for example, let's mark a starting point. Vector A says 3 units to the right, 2 units up. It'll come to this interchange over here. So this is vector A, followed by addition of vector B. So B will be 3 units right and 1 units down. So this will be vector B. Now this is the starting point over here, the ending point over here, and to join up the line we will get S to E. This is vector A plus B. Notice the arrow does not flow in a full circle. There's one of them that goes in the different direction. Please try the following on your own before checking the answers. Have you gotten all the answers? Now, last but not least, let's do some simple addition and subtraction of the numbers. The process is just like adding matrices. So I have vector A, 1, 2, plus vector B, 2, negative 3. So I'll add the x units with the x units and the y with the y units. So this will give me 3 and negative 1. So similarly for A minus B will be processing the x with the x units, so in the negative 1, b with the b units, be positive 5. Take some time and try to work out the rest of the answers. So have you gotten all the answers? We'll continue the next part in tomorrow's lesson.